So a modulus equation is just an equation involving the modulus function or absolute value. And if you don't know what that is, well, let's say you have the number like 3 and take the absolute value of that, it's also 3. But if you take the absolute value of a negative number, like -3, then it turns into a positive number. So the absolute value of -3 is 3. And like the actual definition for it is like the distance away from 0 on a number line. So like at 5, if the absolute value of 5 is just 5 away from 0, so it's also 5. But the absolute value of -5 is not -5 because you're counting the distance away from 0, and it's also 5 units. So the absolute value of -5 is also 5. So yeah. And to solve modulus equations, let's say you have the absolute value of f of x, or the modulus function of f of x, is equal to g of x, and these are different functions. What you have to do is you can get rid of the modulus on f of x and just set it equal to g of x, but you have to set up another equation where it's equal to negative g of x, because as we just learned, a number and its negative component, the absolute values of both have the same answer. And this means that you can do this, or you can set up two equations involving f of x equals g of x, and another one, negative f of x is equal to g of x. And both are the same. You can just do whatever one works depending on the scenario. So I'm going to go through this process using an example. Let's try to solve this modulus equation right here using the steps. So the absolute value of x minus 2 is equal to 2x minus 3. And again, the first step you need to do is just remove the modulus. So x minus 2 is equal to 2x minus 3. And then you need to write a second equation where you turn one of the sides negative, like this. I turned the right side negative here, but you can turn the left side negative if you want to. And you have to solve both equations. This one will get you x equals 1. This one gets you 3x equals 5, or x equals 5/3. So now we have both of our solutions. But you have to plug in both of them into your original equation to make sure both of them work. So let's try x equals 1 first. This would be absolute value of 1 minus 2 equal to 2 minus 3. And we can rewrite this as the absolute value of -1 is equal to -1. And that's not true because the absolute value of -1 is 1. And that's not equal to -1. But now let's try 5/3. So the absolute value of 5/3 minus 2 is equal to 10/3 minus 3. This can turn into the absolute value of -1/3 is equal to 1/3. And this is true because the absolute value of absolute value of -1/3 is 1/3. And those are equivalent. So that means that x is not equal 1, and our only solution is x equals 5/3. And now let's get into some practice problems. So if you think you know how to do this one, pause the video and try it. This problem asks to solve the modulus equation absolute value of 2x plus 3 over 2 minus x is equal to 5. And as always, the first thing you need to do is get rid of the modulus. So like this. And then you need to write another equation where you turn one of the sides into a negative. For this, I'm turning the 5, the right side, into negative because I feel like it's easier. And then you solve both equations individually. This one turns into 2x plus 3 is equal to 10 minus 5x. And then you get 7x equals 7, or x equals 1. So that's one of our solutions, or potential solutions. This one, you get 2x plus 3 equals 5x minus 10, or negative 3x equals 13, or negative 13. And this is x equals 13 over 3. So now we have both of our potential solutions, but we're not done there, and we need to plug in both into the original equation. So first, let's try x equals 1. Absolute value of 2 plus 3 over 2 minus 1 is equal to 5. And that's true because this turns into 5 over 1, which is just 5. And then that turns into 5 as well. So this solution is verified. Now let's try 13 over 3. This one's going to be a little harder to check, but still it's fine. 2 times 13 over 3 plus 3 all over 2 minus 13 over 3 equals 5. And let's simplify this fraction a little bit. We can turn this 2 times 13 over 3 into 26 over 3, and this 3 into 9 over 3, and this 2 into 6 over 3. And then we just get rid of all of the 3's because all of them are divided by 3. So now this is what we have. 26 plus 9 is 35. And 6 minus 13 is negative 7. And this fraction simplifies to negative 5. And as you should know, the absolute value of negative 5 is 5. So this means both solutions are verified. And that means, unlike the first example we did, we have two solutions, so x equals 1 and 13 over 3. And that's our final answer. And now, let's do another practice problem. And if you think you know how to do this one, then pause the video and try it. But this problem asks to solve the equation, the absolute value of 3x minus 1 is equal to 5x minus 11. And you should already know the first steps by now. So 3x minus 1 equals 5x minus 11. Write it without the absolute value. Then write another one, changing one side to a negative. I changed this to a negative. Then solve both individually. So 3x minus 1 equals 5x minus 11. This turns into negative 2x equals negative 10. So x equals 5. That's one potential solution. And this one turns into 8x equals 12. Or x equals 3 over 2. So those are both of our potential solutions. And we need to check both by plugging it into the original equation. So let's try x equals 5 first. So 3 times 5 minus 1, absolute value of that is equal to 5 times 5 minus 11, or 14, absolute value of 14, so just 14, is equal to 25 minus 11, which is also 14, so yes, x equals 5 is a solution. And also, when you're doing this on a test or something, I'm erasing the part where I check the solutions by plugging it back in, just so I could have more room for the next one. But when you're doing on a test, you should not erase the part where you plug it back into the original equation. So now let's try x equals 3 over 2. So absolute value of 3 times 3 over 2 minus 1 is equal to 5 times 3 over 2 minus 11. I can change this into absolute value of 9 over 2 minus 2 over 2 is equal to 15 over 2 minus 22 over 2. And this gets changed into 7 over 2. And this gets changed into negative 7 over 2. So this is not equal because 7 over 2 is not equivalent to negative 7 over 2, which means that x equals 3 over 2 is not a solution, and x equals 5 is our only solution to this equation. So everything that I explained in this video and other problems that I went through should give you everything you need to know to start solving modulus equations. If you learned something from this video or if you enjoyed it, then please consider liking and subscribing.